All right, here we go. We're going to draw the cosecant graph this time. So let's get started. Chapter 4.6, graphing the cosecant function. And let's take a look at the base cosecant function. Who are good friends with cosecant? Well, sine's good friends with cosecant. They hang out. They're reciprocal buddies. They do all kinds of crazy things. So let's see. If we want to graph cosecant, what we got to do is graph sine. It is part of the deal. So that's what I like to do anyway, graph the sine function. But first, we have to ask, so where is sine equal to 0? Because if sine is in the denominator and I get a 0 there, well, that's going to be undefined. So, well, sine is naturally 0 at 0 and pi. Thus, those points, cosecant is undefined. Now, this is not like tangent or cotangent where I'm setting asymptotes equal to the bx minus c part of our function right here in the parentheses. We still set this equal to 0, and we just need to find out where, when we shift the graph, as soon as it crosses over a legitimate x value that is 0, or a y value that's 0, I should say, then we will get something that's undefined. So again, the blue curve is the sine curve. I draw the basic sine curve. Once I'm done with that, I draw in my cosecant curve. That's the green curve. It happens at the peaks and the valleys, or a downward negative peak here. So I go swoop, and then I draw it, and then swoop, like that. And that's all you do. You put in the asymptotes, draw your things, and then we could get rid of the sine curve, but it just acts as a kind of a basis for us in that. All right, let's look at our particular situation. We're given y equals 2 cosecant 3x plus pi minus 1. So we have an amplitude of 2. Yes. We have a period. Pause the video, see if you can figure out the period, even though it's right there. Weird. Okay, so 2 pi over b, which is 2 pi over 3. This is our b value, 3. So we get a period of 2 pi over 3. Our phase shift, again, we set the inside piece, 3x plus pi, equal to 0. And we subtract pi, we get 3x equals negative pi. And then we have x equals negative pi over 3. That's our initial phase shift. So I'm going to go ahead and put that here in my first 0. Always that point, the first one, that's our phase shift. Then I need to find the last 0. How do we do that? That's the phase shift plus the period. So negative pi over 3 plus period of 2 pi's over 3. That gives us positive pi over 3. So I put that here for my last 0. Now, isn't that nice? It worked out well. So I've got half the function here going over to negative pi over 3, the other half going to pi over 3. So it makes a nice easy 0 in the middle. Halfway between there, between negative pi over 3 and 0 is negative pi over 6. Halfway between pi over 3 and 0 is positive pi over 6. So that works out nicely. Now we're ready to graph our curve. Here we go. So we're going to graph the sine curve again, then we'll draw in the cosecant curve. So how do we do that? Well, we have a 0 at negative pi over 3. Remember, it's not at the real 0 line. It's where we moved it down because we've got a vertical shift of negative 1. Our phase shift, we said, was negative pi over 3. Come on, Mr. Dykstra, fill in your blank spaces. So at negative pi over 3, we have a 0. So again, I put it there. I'm going to go to a max at negative pi over 6. So I get a max there. I'm back to a 0 at 0. So remember down here, 0 at negative 1. And then at pi over 6, I'm at a minimum. So right there. And then finally, at pi over 3, I'm back to 0. And we have there. So what'll happen is my graph will go up, curve down, nice curve back there. So that's my graph for the sine function. Now we got to do the part for the cosecant function. Where again was it undefined? It's undefined every time the graph is 0. So here's a 0. I'm going to draw my undefined marks. Ooh, wow, that's terrible. Let's fix that. Okay, so undefined at negative pi over 3. Undefined again at 0. And undefined here again at pi over 3. All right, so we get those. And then, let's get rid of that. That doesn't look good. This looks better. Okay, at negative pi over 3. Now, again, what do we do for our cosecant curve? You got it. We got to draw it in. So, remember, it's on the peaks and the valley here. So what I'm going to do is I'm just going to connect, go whoop, like that. And you definitely have to make that noise when you do it. Whoop. And then down here, we go like that. And then down there like that. That is another whoop turn. So there you have it. The graph, again, is of the... Let's get down here. Come on. Follow me. Down here. Down here. Doesn't want to watch it now. There it goes. Okay, so hopefully you can see that down here. It swoops down and goes lost track. Okay, anyway, hopefully you saw it well. Thanks. Have a great night. We will talk to you soon. Camera, love it.